So our circuit starts over here with a 5-volt power rail, which feeds into a voltage divider consisting of a resistor as well as an IR sensor. The IR sensor is able to change the current that's going through it based on the amount of IR light that hits it. As more IR light hits the sensor is able to pass through more current, which in turn makes a lower voltage reading through the voltage divider. From here, that signal is passed through a high-pass filter, which is able to get rid of any sort of DC offset or DC influence of our signal. From there, this high-pass filter is inputted into an op-amp, which is powered by the same 5-volt power rail that I mentioned earlier. The first op-amp is designed to take the current value reading and the changes in currents and voltages and just make it only a voltage in order to remove any sort of small current differences based on our input signal. From there, our signal is passed to the second operational amplifier located within this circuit element on the other side, where it acts as a bandpass filter, which filters out any signal that's considerably higher or considerably lower than the pulse signal that we're expected to receive. From there, our signal outputs through a resistor and inputs into a transistor, which then significantly amplifies our signal based off the 5-volt power rail on this side, and on the output of our transistor is where we are able to get the appropriately amplified signal to be able to get a pulse reading.
Before the user places their finger onto the photodiode collects a constant intensity of IR light, which in turn produces a constant input signal that is filtered out. However, when the user places their finger between the photodiode and IR light, the finger acts as a buffer between the two. With every heartbeat, the amount of blood flooding through the finger increases. With this increased blood flow, the IR emitter's signal is able to be carried with the blood and delivered to the sensor. This means that with each heartbeat, the IR sensor receives an increased IR intensity, leading to a change in the photodiode's resistance. This creates a non-constant input with each heartbeat to the op-amp. The subject's heart rate can be calculated based on the amount of peaks over a period of time.